Hi students, welcome to today's class. Today we are discussing about ARM programmers model. Okay, so this question can be asked in these two ways. That is, explain the register file of ARM processor with a neat sketch, or draw and explain the ARM programmers model. Okay, now in this session we are studying what is ARM programmers model. Okay, now the programmers model of a processor helps the programmer to use the core component of the processor to program it. Okay, so programmer mode is nothing but it helps the programmer to code the program. Programmer's model of ARM processor includes the details of the main core, registers of the processor, operating modes, and the instruction set. It mainly deals with this programming model mainly deals with the main core and registers of the processor and the operating modes and the instruction set. Okay, the ARM processor has total 37 registers. All registers are of 32-bit size. Okay, these 37 registers can be divided into two groups, that is general purpose registers and special purpose registers. Then the general purpose registers means the registers from R0 to R12 are used as general purpose registers. Okay, we can see the register model later. That is the register from R0 to R12. So this value should keep in mind that R0 to R12 that is used as general purpose register. Depending upon the content, the registers R13 to R15 can also be used as general purpose register. It can be used as general purpose and special purpose. Depending upon the content, it can also be used as general purpose register. The general purpose register hold either data or an address. Okay, so mainly the general purpose register are R0 to R12. In some cases we can consider R13 to R15 also general purpose register. Then the other type register is special purpose register. The registers R30, mainly R0 to R12 is the general purpose register. Okay, then R13 to R15 is and CPSR, that is current program status word, and SPSR, saved program status register. Current program status register and saved program status register are the special function registers. So mainly there are three types of special function registers. First one is R13 to R12, then CPSR, that is current program status register, then SPSR, that is saved program status register. In user mode, register R13 to R12 in user mode are labeled as R13 as SP, R13 SP, R14 LR and R15 PC respectively to differentiate them from other register. So the special function registers R13, R14, R15 are mainly used for specified purpose. So depending upon their function or their specified purpose, it can be named as R13 SP, that is stack pointer, R14 LR, that is link register, and R15 PC, that is program counter. The functions of these registers are given below. Then stack pointer, that is R13 SP. R13 SP, the stack pointer register R13 is a stack pointer register. It stores the top of the stack in the current processor mode. So it stores the address of the top of the stack, okay, in the current processor mode. Okay, so this is the stack pointer. Then what is link register? The register R14 is the link register. The processor store the return address in this register when the subroutine is called. Okay, for in a main program, when we call a subroutine program or subprogram, the address of the return address of the subprogram can be given in the link register. Then program counter, that is R15. Register R15 is the program counter. It stores the address of the next instruction to be fetched from the memory by the processor. So as we know the function of program counter is to store the address of the next instruction to be fetched. So here also the function of the program counter is to fetch the address of the next instruction from the memory by the processor. Okay, so that is program counter. So these are about the registers of ARM7 model. that is special function register and general purpose register. So this is the programming model of ARM processor. Here we have 37 registers. By counting all the registers, we get 37 registers. Each register is of 32-bit size. Okay. So we know that we already studied there are 7 modes, that is user mode and system mode. So this is combining the user mode and system mode. Then this is fast interrupt request, this is interrupt request, this is supervisor mode, undefined mode and abort mode. Okay, so these are different modes, and this is the CPSR register, that is current program status register, and this is SPSR register, this is saved program status register. Now this SPSR is working in FIQ, IRQ and SVC, that supervisor mode, undefined mode and abort mode. Okay, here there is banked registers and unbanked register. The shaded register is called banked register, this section and this section, and the unshaded portion is called the unbanked register. The unbanked register and banked register means so this shaded portion is banked register and shaded portion is unbanked register. Unbanked register is nothing but here the 32-bit are fixed size, but in banked register the size is varied, which will depends upon the current program status register. Okay, the size of the banked register depending upon the changes depending upon the CPSR. Okay, now we can discuss each registers one by one. So R0 to R7 are called unbanked register, and each of the registers refers to same 32-bit physical register in all processor mode. In unbanked register, that is unshaded portion, R0 to R7, this is unbanked register. So in this register the size is fixed, that is 32-bit. In banked register the size is varied, which will depend upon the CPSR. Okay, register R8 to R14 are banked register. The physical register refers by which of them depends on the current processor mode. That's the current status register. It depends upon the CPSR, current program status register. Okay, so there are several modes in ARM. So this can be discussed in detail. That is, the first mode is user mode. It is an unprivileged mode under which most tasks run. This user mode is the only mode which is unprivileged mode, and here the most of the task is taking place in user mode. Okay, so this is user and system mode. The next FIQ is entered with a high priority. FIQ means fast interrupt request mode, and it deals with a high priority interrupt, and this high priority interrupt can be handled very fastly. IRQ means interrupt request mode. It deals with the low priority mode. Okay, then supervisor mode entered on reset, and when a software interrupt instruction is executed, in this mode the processor is in rest state. Then abort mode used to handle the memory access violation. If there is undefined memory, or if there is any change in the memory, or the abort, it will work in abort mode. Then undefined mode, that is UNDEF, is used to handle undefined instructions in the that is instruction which is not in the ARM, which is not ARM instructions, other than ARM instructions. Then the last mode is system mode. It is a privileged mode. It is same as user mode, and using the same it is executed using the same registers as user mode. Out of 37 registers, 20 registers which are shown shaded in figure 1 are the banked register. These shaded registers are banked register. These are 20 registers. Okay, so in total by adding these we get 20 registers. Then banked registers of a particular mode are denoted by R number underscore mode. So banked register can be denoted by R number, that is register number underscore mode. Okay, that is register number R13 underscore which mode, that is interrupt request mode. Then we are writing here IRQ, that is register number R13. Supervisor mode we are using underscore SVC. This is a saved program status register. So this is register, name of register underscore the mode, that is SVC means supervisor mode. So this is how the banked registers are written. This is register underscore the mode. Okay, that is register underscore mode. For example, supervisor mode have banked register R13 underscore SVC, R14 underscore SVC and SPSR underscore SVC. Okay, so registers R8 to R12 has two banked physical registers of each, R8 to R12, R8 to R12. So here we have banked register and unbanked register. The first group of physical registers are defined as R8 user to R12 user and second group are R8 FIQ to R12 FIQ. Two banked physical registers. Okay, so here R8 to R12 there are two banked physical address. That is, this is user or system defined address and also fast interrupt request. Okay, this will cover the two mode, that is fast interrupt request mode and user or system mode. Okay, the first is for user mode and the second one is for fast interrupt request mode. So there are two banked physical address for R8 to R12. Then R8 user to R12 user group is used in all processor mode other than FIQ mode and the other is used in FIQ mode. Okay, register R13 and R14 have 6 banked physical registers each. Then register R13 to R12. This is R13 and R14, right? Register R13 and R14 have 6 banked physical registers. Okay. Okay, R12 and R13 has 6 banked register, R13 and R14. So this is user, this is 1, R13 and R12, this is 2, that is FIQ. For interrupt request we have 3, this is 4, 5, 6. So R13 and R14 registers have 6 banked registers. Okay, this is a bank register, bank, and this is also user bank register. 6 banked physical register. One is used in user and system mode, while each of the remaining 5 is used in one of the 5 exceptional mode. Okay. So we already said user and system uses same registers. So we are writing this R0 to R15. So user mode and system mode will use R0 to R15 and CPSR. But fast interrupt requests only use the registers R8 to R14 and SPSR. The interrupt request uses only 3 registers, that is R13, R14 and SPSR. Then supervisor mode uses 3 registers, that is R13, R14 and SPSR. And define uses also 3 registers and abort also uses 3 registers. But user and system uses more registers. Okay, these two mode uses these all registers in common. But R13 and R14 register will be used by all the mode. Okay, all 6 mode. So user and system mode also, so all 7 mode. So the R13 and R14 can be used in all mode. Okay, one is used in user system mode and while all the remaining used in the 5 exceptional mode. Okay, so one is used in user and system mode R13 and R14 and other 5, 1, 2, 3, 4, 5. Other 5 are used for exceptional modes. Okay, so the current program status register CPSR is accessible all processor mode. It contains condition code flag, interrupt disable bits, the current processor mode and other status control bits. So we can discuss the CPSR, that is current program status register, in next class. So that's all about this, that is program model of ARM processor. ARM processor use in total 37 register. Upon user and system uses common registers of R0 to R15 and CPSR, and all other mode uses different registers. So that's all about today's class. Thank you.